So we should now be a little bit familiar with how we solve a projectile motion problem. But let's take a look at one and just make sure. We've got two bullets. One is fired from a gun, the other is simply dropped. They're fired, and this happens at the same time. This one will be dropped straight down. This one will be fired with a forward velocity of, let's say, 250 meters per second. They both start at an initial height of 20 meters. I want to know, how far will this bullet travel? Well, what's going to happen here is both of these are going to be affected by gravity in the exact same way. Barely talk, apparently. And that gravity is going to cause them to accelerate towards the center of the Earth at a constant rate of negative 9.8 meters per second squared. So as this bullet falls, this bullet will be moving downwards in a vertical direction. However, because it also has that forward velocity, it's going to trace out an arc going towards the ground. Okay? And we mistake this. When we see this arc, we mistakenly think that there's some force that's going to affect it horizontally. There's nothing there. If we were to just keep our camera zoomed in on this bullet as it fell and consider the rest of the Earth moving around it, then we would watch as it just fell straight down. But when we look at projectile motion, we're seeing the bullet flying through the air. And so if we set up a variable list for this, we're going to want to set one up in both x and y. Okay? So we're going to have our x, x naught, v naught, v, a, and t. We're going to have a y, y naught, v and y, v final and y, and a, which is actually going to be g and t. Okay. And then let's change this one. Let's change this to a v naught in x, and this one will be a vx. Okay. We're not going to worry about a final velocity here, but we are going to be able to figure this out. So I've got an x naught. What's my x naught? Well, that's going to be